Good evening, PAD and POS 316ers. This is the part one of a three-part mini-lecture series on hypothesis testing using p-values, t-tests, and f-tests. The focus of our mini-lecture today is, of course, to start off with hypothesis testing with p-values. And this is really covering the material that you heard in class through lectures and through your readings in hopefully a very short format. So what is hypothesis testing with p-values? Basically, we're asking a very specific question. We're testing a specific hypothesis about one random variable or one column of data. This is going to vary. It's different from when we do t-tests or f-tests because we're looking at two or more random variables. In order to do hypothesis testing with one random variable, we use the normal distribution, which is very exciting because the normal distribution has known and specific characteristics that you're very familiar with now, including the mean 0, the standard deviation of 1, and the fact that we can calculate z-scores as measures of dispersion, so where our data is in the normal curve and how far away it is from mean in terms of our z-scores. And then we use our z-scores in order to calculate p-values, and our p-values, depending on how big or how small they are, they tell us whether or not we will reject or fail to reject our null hypotheses. So some of you may be asking, and this is a very good question, if you're still confused, it's okay, what is a p-value? A p-value is a probability statement that answers a specific question. And that question is, if the null hypothesis were true, then what is the probability of observing a test statistic at least as extreme as the one that we observed? So basically what we're saying is if our null hypothesis is true, does our test statistic match with our known dispersion of the data using the normal curve? Or is it outside of what we would expect with that normal distribution and with that known distribution? So in looking and making sense of this statement about what a p-value is, it's very helpful to remember our discussion in class a few weeks ago that null hypotheses are kind of boring. Scientists really want to reject the null because null hypotheses are either saying that what is going on to create the values of the variable that we're looking at are random, in which case, well, it's random and you can't really do anything about it, or we're saying that there's something about the value of the observations that we're looking at that differs from what is known, from what we know about that variable based on subject matter expertise, based on reviews of the academic literature, or based on the specific question that we have for our data. So another way to think about this is that p-values tell us how likely it is that our statistic is randomly generated. So the larger the p-value is over a certain level, tells us that we can fail to reject our null, that our null hypothesis is probably the right hypothesis. Which means, conversely, that when the p-value is very small, that tells us that we have evidence, or we have enough evidence, so that we can reject our null hypothesis and start understanding why the data that we're looking at is different from what is known or is different from some random process. So the smaller the p-value, the greater the evidence that we have to reject our null hypothesis. The larger the p-value, the more likely we are to say that our data fits within what is known or that our data is randomly generated. So what exactly does a p-value do? Well, by calculating a p-value, we can, by calculating a p-value, we can determine if the statistic that we're looking at, which can be a mean, it can be variance, it can be a proportion, is generated by a random process or random chance, if it aligns with what we know already, or if there's something else going on under the surface, if there's some kind of systematic influence or effect that's causing the values of the variables that we're looking at. So it's really important to remember when a p-value is above alpha, and remember alpha comes from the confidence level that we set, right? And if we subtract our confidence level from 1, we get alpha. So if the p-value is above our level of alpha, we fail to reject our null hypothesis. So if the p-value is big, we don't have enough evidence to reject our null hypothesis. When the p-value is small or smaller, when it's under our levels of alpha, we have enough evidence to reject our null hypothesis and start investigating what's going on with our alternate hypothesis. That is, why the data is not randomly generated. So what are the factors that are generating the data? Or why is our data different from what is already known about data of that type? So you'll remember just briefly, alpha tells us the probability that we're going to experience type 1 error. So the smaller that alpha is, 0.01 for example, the more sure we are that we are not going to have type 1 error. However, when we have those small alpha levels that help us resist type 1 error, we increase the probability that we will have type 2 error. And for a more detailed discussion of that, you can go to the mini lecture on confidence intervals and constructing confidence intervals that is on the Blackboard site. So how does hypothesis testing with p-values work? Well, first of all, you need to make a hypothesis, and we're going to cover that. You need to gather your data, which is one variable, so we're talking about one column of data. You need to calculate the p-value by using the z-score or the z-value. You need to compare the p-value to your fixed significance level. So this is something that you set when you're making your hypothesis. That's associated with your confidence level. So again, alpha, which is our significance level, is just 1 minus our confidence level. And then you reject or fail to reject your null hypothesis based on that comparison. So again, if your p-value is greater than your significance level, then you fail to reject your null hypothesis. You don't have enough evidence to reject it. And if your p-value is very small, if it's below alpha, then you reject your null hypothesis. So let's go through this